Hello students, good afternoon all of you. So today we are going to discuss about very important concept, that is the polarization of light. Polarization. So what is the meaning of polarization? What are the unpolarized? What are the Polaroids? What is polarizing waves? What is unpolarized waves? Okay, so scattering of polarizing waves and reflection and refraction of polarizing waves. Polarizing waves, yes or no? So what is the reflection? So reflection is given by, so Malus is a Malus law, very important. One more question, define Malus law, very important question. Similarly, one more important question will be there, that is the Brewster law. Brewster law, very important topic. This topic on these two topics. In this concept, we are going to discuss about very important concept, that is the two. One is Malus law and Brewster law. These two topics are very important. Alright? Okay. So, for what purpose we are learning polarization? For what purpose we are learning polarization? Okay. So, why this polarization is came into our picture? What is the reason behind that? Alright? So, only one concept. What is that? So, previous we learn interference and diffraction, all those things. But with the help of interference and diffraction, we learn only one concept. What is that? The light is having wave nature. The light is having wave nature. That is how we learn only. But we did not speak about what type of wave nature. Which type of wave nature? What is the wave nature of light? That means transverse or longitudinal. So that concept we didn't learn in the interference as well as diffraction. Diffraction is given only wave nature. Interference is given only wave nature. But they did not given so either transverse or longitudinal. They did not given about information. Right? For that purpose, we want to learn polarization. Okay, with the help of polarization, clearly we will learn the nature of light. The nature of light, either transverse or longitudinal, like that only. So with the help of polarization, so we will say clearly this is the transverse nature. The light is having transverse nature. The light is transverse in nature. Transverse in nature. That is given by our famous scientist, so Maxwell. Okay, Maxwell is given that nature, that topic on. That's what according to Maxwell, the light is a electromagnetic wave. Light is not as just wave. Light is electromagnetic waves. These electromagnetic waves are having transverse in nature. Transverse in nature. Electromagnetic waves. And also he told very clearly, so electromagnetic waves is nothing but, so these are having electric field and magnetic field. The light wave is a consist of electric field and magnetic field. That means, so light, we know how light can vibrate. The light, how the light can came out. Alright, that is the vibration of electrons. Transition of electrons. Okay, transition of electrons, vibration of electrons. The electrons are moving in the different direction, different directions. Jumping. Alright. So the electrons is a moving. The electrons are moving, it is a produces magnetic field. So that magnetic field and electric field both are perpendicular to each other. The combination of light is nothing but, the light is combination of electric and magnetic field. Electric and magnetic field. This is the information of electromagnetic wave. This is given by Maxwell. Is given by Maxwell. So for example, according to Maxwell, so he took one of a plane sheet here. For example, in this manner, plane sheet we are having. Okay. is a plane sheet. So this is the, so here we are having, so z axis is a z axis and y axis and x axis and x axis. The waves are moving, so electric field is acting along y axis and magnetic field is acting along z axis, sorry, x axis, in this manner, like that only. So this is the electric field and this is the magnetic field. This is the along z axis, this is the along z axis. So propagation of wave is the propagation of wave. Propagation of wave. So electric field and magnetic field both are perpendicular. Electric field and magnetic field both are perpendicular. Both are perpendicular, as well as, so electric field magnetic perpendicular to the propagation of wave. Perpendicular to the propagation of wave. This is the, so propagation of wave. So that wave is, so having electric and magnetic field. So electric field and magnetic field both are perpendicular to each other. Perpendicular to each other. This is given by Maxwell only. That's what, according to Maxwell, the light is having, what is that, transverse in nature. So if I observe only, so only electric field, if I observe only electric field, we can observe, so in this manner, this is a complete transverse in nature. So this is the electric field only, right? Transverse in nature is the direction of propagation of wave. The direction of propagation of wave along z axis. So this is the, so particle direction. The particle direction perpendicular to the propagation of wave. Propagation of wave. Alright? This is the electromagnetic wave. Okay, so now we are speaking about polarization. What is the meaning of polarization? Right? What is the meaning of polarization? So polarization is nothing but, so just now when I told, what is that? The light is the vibration of electrons. The light can develop, that means that the light can generate, the vibration of electrons. The vibration of electrons, that means, so these are the electrons, like that will be there. For example, these electrons are moving this direction and this direction and this direction and this direction. So yeah, all directions in this manner. So in this manner, so any directions, all directions, the electrons can vibrate. The electrons can vibrate. So now I will consider here one plane of paper, plane sheet. Okay, plane sheet. So now this is the, so, and also remember here, what is that? This is the electric and magnetic field I given, right? This is magnetic field, is the electric field. So now electric field is acting in this direction, magnetic field is acting in this direction, correct? So electric field and magnetic both are vector quantities. Both are vector quantity. That's what here. So electric field we can call it a light vector. Is electric field we can call it a light vector. Remember everybody, light vector. Okay. So is a not only one direction. It can vibrate in this direction and it can vibrate in this direction. Which one? Light. And this one vibrate in this direction. It can vibrate in this direction. Right? This is the can vibrate in all directions. In that case, this intensity is maximum will be there. Is the maximum. Its intensity is maximum. Its intensity is maximum. At the same time, this light is called unpolarized light. What is this? Unpolarized light. Why sir unpolarized mean? Is the intensity is more. Intensity is more. Do not have only one direction. Polarized mean the light can move only one direction. Only one direction, either x direction or y direction or z direction. But unpolarized mean it can vibrate in all directions. It can vibrate all directions. That is nothing but unpolarized light. Unpolarized light. Now this unpolarized light, UPL, unpolarized light, we want to convert to polarized light. We want to convert as a polarized light. Okay, this process is known as polarization. This process is known as polarization. Remember, polarization is nothing but it is the process of transforming unpolarized light. Transforming unpolarized light into polarized light. Polarized light. This is called polarization. This is called polarization. Okay. So what is the meaning of unpolarized light? This is unpolarized light is the front view. This is we can see here. So in front view. Correct? So and also this is the vector form only, right? This is the vector form. So now this is the result in the vector mean this is the adjacent side, this is the x component, this is the y component. Is the resultant vector mean this is the x component, this is the y component. So that now resultant is becomes like that I can draw. So this is the resultant vector. Is the result vector of x component, y component. Alright. Similarly, this is the resultant vector of y component and x component. Alright. So next, this is the resultant vector of y component and x component. This is. So it goes like that, it comes like that, it comes like that, it comes like that. Alright. So now this is the we are having two directions. Correct? So this is the y direction, this is the x direction will be there. If I see front view, I can appear, it can appear like that itself. Okay. So this is the direction of propagation of light in this direction. This is the direction of propagation of light. So this is the electric field and magnetic field. Both are perpendicular to each other. Okay. So now this is. And also if I say side view, is a front view I have given. If I see this is a front view, if I say side view in this manner mean, so this is the y axis, this is the x axis. Yes or no? If I see like that mean x axis can appear, y axis also can appear like that. But if I see mean what happened? Only it can appear in this manner only. But this is the coincide with here itself. That will completely it will comes like that only. Correct? So now in this case it can appear front view. This is the front view, side view. So side view. This is the y axis. Okay. So now here, is the same this side only. Now it will comes in this manner. So now that is did not appear proper way. That means we did not find. Correct? So two lines. It can appear only single line. In this manner. So that in that case we can represent it as light wave in this manner. Light. Okay, electric field and magnetic field we can represent as like that only. Only one direct like that will be there. But dot symbol is what? Dot symbol is is a perpendicular to in this manner. This is a parallel. Is a parallel direction. This is the perpendicular direction. Okay. So in this manner we will represent. Remember, what is the symbol? These are symbols of unpolarized light. Unpolarized light. This is the unpolarized light. This one also unpolarized light. And this one also unpolarized light. So in unpolarized light is having more intensity. That is the important point. which is having more intensity, the total light it can enter into our eye, then what would be happen? The eye will get a little bit disturbance. Correct? The eye will get a disturbance. Then it will get disturbed. That way, that much intensity can increase mean energy is more will be there. Yes, sir. Intensity mean so it is having more energy. That much energy can enter into our eye mean our eye will get some defect. Correct? Definitely it will get. That's what here. So most important applications also will be there. Yes or no? So sunglasses. We are using sunglasses. For what purpose? So we'll get protection from sunlight. Correct? Protection from sunlight. Similarly, our car windows are having window glass. That window glass, because of window glass, we are getting less intensity of light, less intensity of sunlight. Correct? So we have that one also a Polaroid glass only. That one also Polaroid glass, and sunglasses also Polaroid glass. So these are so many applications are there. Yes, sir. 3D pictures, 3D videos, these are all. So with the help of polarization only, this and all can possible only polarization. Are you clear? Okay. So now this is the unpolarized light, which is having more intensity, Right. So now I want to reduce that intensity. That purpose, what I want to do. That means I want to reduce that intensity. That means all incident rays I don't want. I want to only so some intensity light. Correct? So many directions, so many light vectors are there here. All directions. But I want to only single direction. Single direction mean only one direction mean. So intensity obviously can decrease only, right? Obviously can decrease only. So now I'm asking question, that is only I want to reduce the intensity. That is nothing but, so this one, what is that? The process of transforming unpolarized light into polarized light. The polarized light is intensity, so nearly half of the unpolarized light intensity. Nearly good half of the unpolarized light intensity. Which one? Polarized light intensity. For example, so unpolarized light intensity, if I take, I mean, okay, so polarized light intensity becomes I by 2. It can reduce the half of the intensity, half of the percent. Okay, so this is the, I mean, this is can decrease half of the intensity. Half of the intensity means, so we will get less defect only. Correct only, right? Our eye did not get any defect. Why? Because intensity is decreases. The intensity decreases because of polarization. That means unpolarized light is converted into polarized light, PPL. Plain polarized light. This is the, so what is that? Unpolarized light. So PPL mean plain polarized light. We want to convert. Alright, then what is the meaning of polarized light? Polarized light is nothing but, so many definitions I have given. So this is the easy definition you can see once here. What is that? It is a wave in which the direction of vibrations is strictly confined to a single direction. Here more directions will be there, but we want to get only single direction in the plane and perpendicular to the direction of propagation of wave is called polarized wave. is called polarized wave. That means a wave in which the direction of vibrations is strictly confined to a single direction in the plane and perpendicular to the direction of propagation of the wave is called polarized wave. Polarized wave. That means, so I want to convert this unpolarized light into polarized light. That means, so here this is the, so remember this is unpolarized light. Generally we can represent it as like that itself, is the unpolarized light. Now this is converted into polarized light. Polarized light. This is the direction of propagation of light. Is a dot symbol will be there here. Dot symbol and arrow symbol. But here only arrow symbol or dot symbol. Dot symbol. This dot symbol we will consider as a perpendicular. This arrow symbols we can consider as the plane direction, plane of the Polaroids, plane of the Polaroids. This is here one important word I mentioned there. What is that? This is nothing but Polaroids, polarizers are also Polaroids. Polarizers are Polaroids. These Polaroids are having one axis will be, that is the, what is that? Pass axis is a pass axis. Pass axis nothing but here only single slit, like that itself. Single slit mean opening. This opening either x direction or y direction or z direction. Any direction will be there. The direction is any direction. So remember, what is the meaning of Polaroid? Polaroid is nothing but, this is the, in this manner, this is generally Polaroids is made up of, some crystals will be there. Some crystals, that is the tourmaline crystal and nickel prism and tourmaline crystal. So tourmaline crystal, tourmaline crystal or else one more will be there. So this is the, example of Polaroids, nickel prism, nickel and nickel, NiCOL also. Some books will be there, NiCOL, or some books are NiCHOL, nickel prism. Okay, these are the objects, tourmaline crystal and nickel prism. Ca. So nickel prism is nothing but CaCO3. So nickel prism is made up of CaCO3. Okay. So this is having pass axis like that one. This is the pass axis, means small slit gap. This gap is either x axis or else y axis, like that will be there. So in this manner. Okay. Or else z axis. Any direction will be the slit. Slit is having like that itself. But only one direction. At the time do not have all directions. This polarized slit. This is having only one direction. Either x axis or y axis or z axis. That slit will be that gap. This gap. For example here, these rays is the moving in the, which all directions, right? That is like that will be there. This is, x direction and y direction and z direction. Yes or no? In this manner will be there. For example, this is the y direction, mean y rays will comes out. Y direction waves only will comes out only. Correct? For example, this is, I can rotate in this manner, x direction. This slit I can rotate in the x direction. That means in that case what happened? So x direction waves only will come. X direction waves only will come. If I rotate, that is along the axis. In that case what happened? So the parallel to the rays are which are parallel to that what is that slit, which rays are parallel to this slit, that rays only will come. That rays only will come. Correct? Remaining waves are does not. Remaining waves are does not here only. So for example here, so this is the y-axis will come here. So x-axis does not come here. So this z-axis also does not come. Does not come. Only one direction waves will, the single waves, single light waves only will come outside. That waves, these waves are called polarized waves. Right? Is that definitely what is that? A wave in which the direction of vibrations is strictly confined to a single direction in the plane and perpendicular to the direction of propagation of wave. Propagation of wave is called polarized wave. And one more definition. What is that? The phenomenon by which the vibrations of light are restricted, this word important, restricted to a particular plane is called polarization of light. Polarization of light. Okay, polarization of light. Only particular direction, only single direction, not a all direction. That is nothing but a polarization of light. Is nothing but polarization of light. That waves are called polarized light waves. This process is nothing but polarization of light. Polarization of light. Are you clear? This is the concept of polarization. So now, so what is the meaning here? What is important? So unpolarized light converted into polarized light. For that purpose, what is required? Polaroids are required. What is the meaning of Polaroids? Now I will give small definition of Polaroids. Right. What is the Polaroid? Polaroid is nothing but it is the consist of long chain of molecules aligned in a particular direction. It is a, what is that? A Polaroid. Polaroid is nothing but it consists a long chain molecules aligned in a particular direction. Particular direction is nothing but Polaroids. So examples are, so what is that? So tourmaline crystal and nickel prism. This is the, so Polaroid diagram. Remember my Polaroid diagram. So we can represent it as, so in this manner, which is having pass axis like that itself. Okay, this is nothing but a pass axis. Tourmaline. Okay, crystal, nickel prism. Nickel prism is nothing but, so two prisms are so combined in this manner. Nickel prism. So CaCO3. So we will join with help of, so one gum will be there. One gum. Okay. So here with help of gum. So then that gum name also will be there. Okay. So one gum. So here with help of gum, so we can join these two prisms. So this is the nickel prism. This and all we will learn in the neat purpose only. Later I will explain that is. So this is the tourmaline crystal and the nickel prism. This is the Polaroid. Okay. So then, with the help of Polaroid, what would be happen? We will reduce the intensity of electromagnetic wave. That means the electric field intensity should be decreases. Okay, The light is fall on the Polaroid, the intensity should be decreases. So now what happened here? So two experiments I will give you here. So experiment 1 or observation 1. Okay, single Polaroid. Single Polaroid. Single Polaroid. For example, here I have, so what is that? So here unpolarized light. Unpolarized light. Unpolarized light along this direction is the unpolarized light. So we can represent as like that itself. Is the direction of propagation of wave. So now here we will keep which one? So polarizer. I will keep here polarizer. Okay, this is the P1 I will consider. Is the P1 single polarized. Right, single polarized is P1. Okay, which is having pass axis. Which is having pass axis. Then what happened? So polarized light waves will come in this direction. Polarized light. Okay, so its intensity, so I is there, means this intensity becomes I naught. I naught is equal to I by 2. I by 2. Okay, intensity is equal to how much? I by 2. Half of the intensity should be decreases. Half of the intensity should be decreases. Okay, so this is the single polarized. For example, if I use experiment 2, intensity, remember intensity is the same, intensity is decreases half of the intensity. So experiment 2. So now double polarized, that means two Polaroids. I can use. So here this is the polarized light, unpolarized light is the unpolarized light. Okay, so now I can use here, so one of a Polaroid, this is the P1, is the P1. So now this is the pass axis, in this manner will be there. In that case what happened? So now these are polarized light, is the polarized light. That means one question, sir, if I keep this one, so these rays are, how can you say that is a polarized light, sir? How can we say this is the polarized light? For that purpose we want to use another Polaroid. That another Polaroid we can call it analyzer. What is that? Analyzer. That means we want to analyze. That is the Polaroid, that means unpolarized light or Polaroid light. Like that we want to analyze. So that purpose we can use here another Polaroid. This one we can call it analyzer. We can call it analyzer. Okay, this one also having, for example, pass axis in this direction okay, so then what happened here? So only this direction waves only come outside, will come outside. Okay, will come outside, only that direction. For example, this intensity I naught means this intensity also I naught. That intensity also I naught. Correct? So now we are observing like that, this side only. For example, here these rays are high intensity is there, mean these rays are do not get any polarization, like that we will say. Do not have any polarization, polarizing nature, like that we will say. But these waves are having less intensity comparatively this one mean. So in that time we will say these rays are polarized. That means so with the help of Polaroid, so we got polarized light. Like that we will say with the help of this one analyzer. Correct? So, for example, both are this P1 and P2 both are in the same direction. That means here theta is equal to 0 degrees. Which one? Which one? P1 and P2 both are parallel to each other. Parallel to each other. In that case, what happened here? So the intensity does not change. The intensity does not change. Then, for example, here, so I will keep here which one? So P2 little bit. So in this manner. Okay, that means here I will change the angle only. That means slit. Shape I can change. In which direction? So in this direction I will consider. So 90 degrees. This is the slit. Is the slit. Now this polarized light. Did you observe here? No. Correct? Why? Because so this is the not a path parallel. Correct? So this is the waves are moving in this direction mean. So this is the parallel mean like that will come this side outside only. For example, if I keep like that mean what happen? It can stop there only. It can stop there only. That means these lights are cannot go outside. Why? Because the path is not a parallel to. So these waves not a parallel to these waves. In that case, what happened? Here I is equal to 0 will come. This is the I naught. Is the I naught. So this is I is equal to 0. But here I is equal to I naught. Here also. But I is equal to I naught. I is equal to 0. Why? Because so P1 is perpendicular to the P2 is perpendicular to the P1. That is path axis. Path axes are both are perpendicular. Path axes are both are perpendicular. In that case, what happened? The intensity is becomes 0. Your intensity is 0. Your intensity is maximum. That means here how much my intensity will be there. Here also same will be there. Okay, that is. So next one more will be there. So sir, for example, the two Polaroids making some angle. That means not a parallel, not a perpendicular. So it is making some angle. In that case, what would be happen? What would be happen? That is given by famous scientist Malus. Famous scientist Malus. Okay. So so now angle is so the angle between two path axis is theta. Like that will be theta I took there. Okay na? So then what would be happen? So this is the polarized light, unpolarized light, sorry. Is the unpolarized light. So now this is the path axis. Sorry, what is that? Polaroid. Is the Polaroid I will consider in this manner. Polaroid I will consider in this manner. Okay, now path axis, this one is the path axis. So now one more Polaroid will be there. So these are the Polaroid light waves. Next here second Polaroid, but axis I will consider in this manner is the path axis. Path axis. Right, path axis. Then what is the here this is the this path axis like that will be there. Is the path axis in this manner will be there. That means this is the what is that second Polaroid path axis. This is the first Polaroid axis. Yes or no? That means this intensity I will consider I naught, but that intensity is equal to how much? That intensity is equal to how much? Here making so much angle here. That intensity this I this one. What is that? So path axis is making some angle in this direction. In this direction. Okay. So is the making going in this direction. So here this one is the making theta here. Making theta. Correct? Making theta. Its amplitude if I take A naught, its amplitude if I take A naught, alright, then its amplitude what would be happen? So definitely decrease, correct? So that now I can resolve this one two component, so x component and y component. So in this component, and this is the with respect to this theta, with respect to this theta. Okay, so this is the x component, this is the y component, x component and y component. In this direction, what is that? If I take, this is the amplitude, so how much? So if I take, this is the a naught, I took the right, so this is the a naught cos theta, a naught cos theta, this is the a naught sin theta intensity, sin theta intensity. Therefore in this direction, intensity is equal to how much? In this direction, amplitude is equal to how much? A, I will count, this is amplitude A. Therefore A is equal to, yes or no? A is equal to a naught into cos theta, a naught into cos theta, correct? A naught into cos theta, squaring on both sides. Therefore what happened? A square is equal to a naught square cos square theta, cos square theta. We know amplitude, so I is proportional to a square in general formula, correct? So I naught is proportional to a naught square, a naught square. Therefore a is equal to I and a naught is equal to I naught is equal to cos square theta. This is a very important formula. What is it? Malus law. This is what? Malus law. Malus law, very important, Malus law. So definition, what is the definition? The intensity of these waves is equal to, so the product of I naught and cos square theta, cos square theta. So we can define in this manner. So definition I will write there, right? So Malus law is nothing but when a completely plain polarized light, completely plain polarized light is incident on an analyzer, incident on an analyzer, the intensity of emergent light wave, analyzer, the intensity of emergent light wave as the square of the cosine of the angle between the polarizer and the analyzer. Okay, so when the completely plain polar light is incident on an analyzer, the intensity of emergent light wave, intensity I can represent here I. Okay, intensity of emergent light wave as the square of the cosine of the angle between the polarizer and analyzer, correct? So this is the, so what is that? Polarizer, this is the analyzer. So between angle is theta, between angle is theta, so its intensity is, so amplitude is A, is a naught is amplitude S. How much I will consider? So for example, so generally also, so this is the amplitude of polarizer. Now this is the, can bend in this direction mean, so it can move in this direction, that means, so the size should be decreases, the size should be decreases. This is the A. Okay, so now this is the theta, mean this one also theta. So now this intensity how much? A naught, correct? Intensity is A naught, general formula, general method, right? So now cos theta is equal to, what is that? Cos theta is equal to adjacent side by, so hypotenuse, adjacent side by hypotenuse. Therefore A is equal to A naught into cos theta, squaring on both sides. A square is equal to A naught square into cos square theta. So formulas you know already. This is the I, this is the I naught into cos square theta, cos square theta. So like that this formula will come. right? So this is the method, one more method also. So this is the formula. I is equal to I naught into cos square theta. I into I naught into cos square theta. I is, what is that? I is equal to the intensity of emergent light wave. Next, I naught is equal to the intensity of plane polarized light. Plane polarized light intensity. Okay, this is the Malus law. So Malus law finished. So now next topic. So experiment 1, experiment 2 I have given. So next concept is reflection and refraction. Reflection and refraction. So it's another concept. Right, very important concept, that is the polarization by reflection. Polarization by reflection. So what is the meaning of polarization by reflection? So as usual, I will consider here, so what is that? Reflecting surface is a transparent surface. Okay, so now this is the incident ray and this is the normal. This is the normal, this is the reflecting ray. So now here this is the medium 1, this is the medium 2. So now here I will consider so small another medium. This is the, for example, another medium I will consider liquid. Another medium I will consider liquid. Okay, this one also very important concept. This is given by so famous scientist. So that is the Brewster law. So Brewster is given one concept, important concept here. So you can remember everybody. This is the last concept of this so polarization. Okay, this is the instant ray. This is the unpolarized light waves. Unpolarized light waves. This is the angle of incident. This is the normal. This is the normal angle of incident. This is the angle of reflection. Also, you will consider I. Is the incident ray and the reflected ray. So point of incident, some value, that means completely polarization. In the polarization concept, so some part can reflect, some part can refracted. So some part can refracted in this direction, some part can refracted. That means most of the case, that means most of the so light can reflected. So now I can represent as here dotted symbol as well as so perpendicular symbol. Okay, but here completely, so most of the case unpolarized light will come. Unpolarized light, so so in this manner will come. So this is the refracted ray, this is reflected ray. This is a refracted ray. This angle of incident is the angle of refraction, is the angle of refraction. This is a refraction. Okay, in that case. So now is a reflection, and also remember here, so such a type of phenomenon is known as partially polarized. This is what partially polarized. That means completely I want to either dot or so arrow symbols. This is completely like that. Is there mean is a complete polarized. This one also complete polarized. But some cases partially polarized means so in this manner and in this manner. So like that itself. So like that will be there. That will partially polarized. This is called partially polarized. That means here reflection. So for initially generally here what happened here, so complete polarization, complete reflection is does not possible, does not happen. So some portion is like that will be some portion like that. This is a completely, that means so almost all this is unpolarized light only. That means refracted ray almost all what is that? Unpolarized light. So now reflected ray partially polarized. Now I want to complete polarized reflecting ray. I want to complete polarized reflecting ray I want. In that case, so we want to do so one situation there. What is that? I want to change this angle of incident. I want to change this angle of incident. That means so that ray will comes in this direction or in this direction, any direction. But condition, remember. Okay, what is that condition? So exactly the angle between reflected ray and refracted ray is 90 degrees. Is 90 degrees. In that case, that particular angle, this reflected ray completely plane polarized. Okay, plane polarized, completely plane polarized, not a partially polarized, completely polarized light. That polarized reflecting ray can form. That when that condition, when the angle between reflected ray and refracted ray, the angle between reflected and refracted ray is exactly equal to 90 degrees. In that case, so we will get complete polarization, complete polarized reflecting ray can form. Okay, in that particular situation, angle of incidence is called polarizing angle. What is that? Polarizing angle. Angle of incidence IP mean angle of reflection also IP. What is the meaning of IP? Polarizing angle or Brewster angle. Brewster's angle. That is given by scientist Brewster only. So this is a given experiment complete is given by Brewster only. That's what we are calling. That is Brewster angle. Brewster angle. Okay. Then, so what is the relation between Brewster angle and here one medium will be there. This is the mu I will consider refractive index of medium, any medium. What is the relation between refractive index and Brewster angle? What is the relation between refractive index and Brewster angle? Very, very important. That is given by Brewster only, so that we can call it, that is the Brewster law. Is a Brewster law. So now I want to Brewster angle IP is equal to what? IPR IB. So IPR theta PR IB. So IB Brewster angle we can call it, that is Brewster angle. Okay, so now I want to Brewster angle. What is the relation between mu and Brewster angle? So now I will consider here, you can observe here, this is a normal, this is a reflected ray, this is a refracted ray, this is another normal. So the total angle from here to here, so total angle is how much will come? 180. So therefore from figure, what we can write here? From figure, so what is that? IB plus 90 plus R is equal to 180 degree. Correct? So now I want to R itself. R is equal, what is R? Angle of refraction. So 180 minus 90, 90 minus IB. Brewster angle. Okay? From Snell's law. From Snell's law, what we can write? So you know Snell's law. Mu is equal to sine I by sine R. Angle of incidence, angle of refraction. So mu is equal to sine I. Sine I is equal to, what is that? Sine I B sine R. R is equal to how much? R is equal to 90 minus IB. 90 minus IB. What is 90 minus IB? Sine 90 minus theta. Cos theta. Cos IB. So mu. Okay. So sine by cos is nothing but a tan. Tan IB. Therefore, remember, very, very important formula. So mu is equal to tan IB. Mu is equal to tan IB. This is the relation between Brewster angle and refractive index. Refractive index, that's what here, the refractive index of given medium is equal to the tangential of the tangential of angle of incidence. Angle of incidence. This is called Brewster angle. So now Brewster law. What is the meaning of Brewster law? What is the meaning of Brewster law? What is the meaning of Brewster law? So now I will give you Brewster law for definition. Right, Brewster law. What is the Brewster law? So Brewster proved that the tangent of angle of polarization, the tangent of angle of polarization IB is numerically equal to the refractive index of the material of the reflecting surface. What is that? It is the IB tan IB is equal to the refractive index of material of the reflecting surface. That's it. Okay, this is the Brewster law. So tangent of angle of polarization, is equal to the refractive index of given material medium. Okay, material of the reflecting surface. Right? So that is the Brewster law. Similarly, the relation between IB and IC. IB means Brewster angle, IC means critical angle. So we know that critical angle relation. What is that? So sin IC is equal to 1 by mu. Correct? Sin IC is equal to 1 by mu. Therefore, mu is equal to, what is the mu is equal to? 1 by sin IC. 1 by sin IC. Therefore, instead of mu, we will consider 1 by sin IC. So, tan IB is equal to 1 by sin IC. This is the relation between. Tan IB and sin IC. Sin IC. Tan IB is equal to 1 by sin IC. This is the Brewster angle. So finish one. This is the Brewster angle. So reflection over refraction also same only. So Brewster concept. So polarized. That means reflection is completely polarized, but refraction is not a polarized. Yes or no? So almost all unpolarized light only. Refracting light. Refracting light is unpolarized light itself. Okay. Similarly, lost concept. What is that? Polarization by polarization by scattering. This one also very important. So with the help of this is done by our famous science C.V. Raman only. Okay, C.V. Raman is done this experiment. Because of that, this experiment he got a Nobel Prize on scattering of light. So generally scattering of light is nothing but, we are observing here, what is that? This is the sunlight. Sunlight is the unpolarized light. So in this direction, will come. For example, this is the unpolarized light comes in this direction into the air. Okay, here air molecules are there. Air molecules are having electrons. So these electrons can vibrate either x direction and y direction. Okay, it can vibrate only x and y direction only. Correct? So now here the electrons can observe this light and it can vibrate. So which direction? Either x and y direction. So for example, here observer will be there. Is the observer here will be there. Is the observer. Okay. So then what happened? So it can observe. He can observe. So the light can reflect in this direction. He can observe this light reflection. it can light plane polarized. Plane polarized. It can observe this one only one direction. It can observe at a time two directions. So like that will be there. So you can observe only one direction. Correct? Only one direction. He did not observe. So two directions. Right? That means the light the electrons can vibrate only one direction. Only one direction. So either x direction or y direction. So that's what here the person can observe like that. That means the molecules can observe the light energy. It can emit the radiation. It can emit the radiation of light. So that radiation of light can observe by this person. That person. Okay, it can vibrate in this direction as well as another direction. Any direction. But all directions are not possible. Electrons does not move in all directions. Only electrons can vibrate only so in this direction or else in this direction. Only one direction. This is the scattering of light. This is given by our famous scientist C.V. Raman. He got Nobel Prize also with help of this one. Right? Okay. So now last concept of polarization. What is the last concept of polarization? Uses of polarization. Uses of polarization. Applications of polarization. Applications of polarization. We are having so many applications. Okay. So many applications are there. So some applications I will give you. That one you can observe clearly. So first application. First application is to produce the first application to produce and analyze plane polarized light. First point, what is that? To produce and analyze plane polarized light. That is the first point. Second point, for making sunglasses. For making sunglasses purpose, so polarization is useful. Right? Next one. So to see 3D pictures and movies. 3D pictures and movies. For that seeing purpose also, so that one also made up of polarized light only. So next one, in photographic cameras, in filters, in 3D cameras, that also we are using our Polaroids only. So to control the intensity of light entering trains and aeroplanes, correct? We are using polarized glass. So in aeroplane and trains and cars, that windows is the window glasses is made up of polarized plate only, polarized material only. So because of polarization we are getting less intensity, otherwise we will get more intensity. Are you clear? So to study the optical properties of metals, optical properties of metals, so like there are so many applications. These are the some applications of polarized what is that? Applications of Polaroids. Applications of Polaroids. That's it, ma. So this is the concept of polarization. So very important concept. You have to read this concept clearly and you can remember. Right? Thank you to one and all. Thank you.